Thank you, Peter. Next, we are gonna hear about 6G and how it's going to change our life. Welcome to the stage, Professor Ari Pouttu from University of Oulu.
All right. Thank you, thank you all. I was first trying to figure out a way how to describe the use cases, the visions of 6G. Either I was incapable or too lazy to do that, so I took a video. It's about 4.5 minutes, so let's use that, and then I will talk to you about 6G for about 10 minutes. But first I get to breathe for 4.5 minutes, and then we go. So the number of use cases obviously is almost unlimited. Um, so let's go into the slides then. How do we get the, like this? So I will talk a little bit about the 6G. First, what is 6G? Nobody knows. Obviously, it's the answer at the moment. But let's start first looking at the Gs. They appear every 10 years. So there was 1G, 2G, they were about speech. 3G, 4G was about more mobile broadband, so bringing the internet into our pockets. And now we have embarked on a journey of connecting trillions of objects and trillions, millions of processes and bringing in new digital services. So basically automating the society as much as we can. So 5G will start the journey that will be, in quotes, completed by 6G. And this is the first evidence that it appears that even though the Gs come every 10 years, the market transformation happens in cycles of 20 years. So, what is a few words about the program that we have been doing here in Oulu since 2018. It's about 8-year program, about 250 million euros. It's operated by the University of Oulu, and obviously we have a lot of collaborators: Nokia, VTT, Aalto University, Business Oulu, Oulu University Applied Sciences, Keysight, India Digital. These are what we call co-creators. And then we have 300 project partners in different projects funded by EU, funded by Business Finland, funded by many different sources, and obviously the companies by themselves. When we initiated the program, we decided, okay, we need 4 different research areas to come up with the 6G solution. First one, obviously, is the wireless connectivity. How we boost the capabilities from 5G to 6G, even more than the 5G will promise us. And we decided, okay, let's go for ridiculous speeds. 1 terabit per second on wireless domain is the target that we have set for ourselves. And then on the other hand, ultra-reliable low latency communications. There are a lot of applications, holography, industrial process control, self-driving cars that really need very, very low latency. The 1 millisecond promised by 5G is sufficient for many different applications, but there are more. Then this 1 terabit per second tells us that we need a huge part of spectrum to be able to transmit such data rates. And that means we need to go higher in the spectrum. And then we start having this problem that the semiconductor materials used to build our circuits, they start to fail around 100 gigahertz. So we need to figure out new semiconductor materials to be able to go beyond 100 gigahertz all the way to 300, 400, even 1 terahertz frequencies. So new materials. New materials, higher frequencies, new physical phenomena also start to happen in these materials. We need to either compensate them or exploit them in our next generation circuit designs. And this means again that when we do new circuits in new fashion, it means that we need to figure out how to manufacture these circuits again. So that's devices and circuits. Third area is the fact that we will, in the 6G era, have computing elements everywhere in the network. That is not the case in 4G, and 5G already has the capability, but it's not anywhere there yet. 5G will introduce later on compute capability as a function within the network, so bringing in the capabilities of process, artificial or machine learning way, really fast processes nearby, making these real-time society a possibility. Services and applications. 2 areas. How do we consume data in 2030s? Is it a smartphone? Partially, yes. But it seems to be that wearables and holographic communications start to take place more and more when we go further into 2030s. So new ways to consume data. And then the value networks. The 6G networks, when we go to those higher frequencies, they will be mostly indoor networks. Now, when they come indoor, what happens? They come to premises which are owned by somebody. And this will break the mobile operator paradigm rather seriously. A new type of operators start to appear, which operate, one operator might operate hospitals, another one factories, third one shopping malls, fourth one campuses, fifth one stadiums. So new business opportunities will appear because the paradigm is changing. We go indoors where the building owners now have a say. So we had these different type of things. One was the high data rate. So there are a lot of different things that you can provide when you go higher and higher and higher in the data rate. Holography, real huge experience, immersive experience, in extensive, really huge XR type of things where you have 16K videos with huge high refresh rates, in-chip radios, in-device radios, data center connectivity, so replacing the cables, whatever, data kiosks. Then on the low latency side, when you go to the left upper hand corner of the box, high hysteresis-free remote control with haptics. So you need to really feel if you do a surgery. You need to feel what you are doing, and you cannot have long delays there. Then in the low jitter corner here, again, holography. When you start to bringing a lot of different streams from different places, you need to synchronize them really good. Otherwise, your picture starts to look. And then, new thing that appears with 6G is imaging and sensing. Your devices will have thousands, even tens of thousands of antennas, and it starts to resemble sort of like pixels in your camera. And your radio signal, while it's transmitting data, can actually take pictures of its environment and sense what's there. And this will bring totally new capabilities. Real-time digital twins and real-time remote control from the virtual digital twins. Again, holography will benefit from this. Extreme swarms, material identification, and then you could, if you have capability of using radio signals for imaging and sensing, you could bring the list down like. Anyway, this I already mentioned, local operator. We already in 5G era, in countries where regulations were more relaxed than, for instance, in Finland, like Germany, they already have 120, 130 private networks operated by private parties or mobile network operators. So we start to see this 5G, 6G change already now. And as I mentioned, new things will appear when you go higher. You start to get these new capabilities, terahertz imaging, millimeter level positioning, sensing of the environment, fire guys, they go into smoky building, they can see through the smoke. This is one thing that seems to become very necessary in the future. You need to have real-life testing environments for testing and proving to different vertical industries that these solutions that we are providing you actually work. They bring value to you, and they bring sustainability in your business. So these test networks are something that we need to have. This is slide of our own, which we have in Oulu. So we are going towards 6G test network. We are now having this millimeter wave 5G, 3.5 gigahertz 5G, and we expect to have in 2 years' time the first 6G type transceivers capable of doing not terahertz, not terabit per second, but maybe 150, 200 gigabit per second. And eventually have some kind of a first 6G test network around 25. And the time frame expected for these 6G technologies to become really real life products in the market is around 2030s. So there is still time to do the research. time to figure out what is a good business case in 5G and then eventually 6G era, and figure out why the mobile cellular, the last mile, why it will be more important. They will replace credit cards. And it will be the only, one of the main streams to access any platform service in the world in the future. If it's a mobile phone, it's clumsy, but then wearables, some kind of new devices will appear which will make it easier for you to do it. We are using this test network as a platform for digital services in our university. There is a project called Smart Campus, which is run by 8 universities, University of Applied Sciences in Finland, and we are capable of building on top of this wireless platform, wireless network, digital services that can be tested in these kind of test environments. And if you want more detailed information about 6G, it's not available. Well, it should be available, but for some reason, this one doesn't work. We have written several white papers within the 6G flagship, which describe different parts of the 6G future. Not only technology, obviously there is wireless connectivity, machine learning, localization, sensing. All of these are dealt with in detail in these white papers. But there is also business. What is 6G business? What are the sustainability aspects of 6G system designs? And that's about it. So I guess I end here and let somebody else continue. Thank you very much. I guess if you have time, yes. When we do the final system design phase starts in a couple of years' time. We start to look at different system design objectives, which are requirements for making the system providing sustainability, not only to ICT itself, but for all the different verticals it's going to enable in terms of giving them mobility in wireless. For instance, the system can be used to measure everything in the environment and then optimize performance of a process. Or there are 4 billion unconnected, unserved people in the world at the moment. One criteria we have set for 6G system is reach everybody. That's again providing sustainability towards the UN Sustainable Development Goals, because information is key to most of the SDGs provided by United Nations. And if we succeed in 6G design, providing either local or global connectivity to every person in the world, we have contributed to most of the SDGs already. And then we can use the system to measure what's happening in the world, to optimize further everything, provide services that provide something for poor communities, such things.
But it's so hard to imagine, like the different companies you're talking about. We have planned obsolescence in the electronics in the market right now. Like 5G is coming, and 6G comes, these technologies that they 10 to 20 years. We are not discarding our equipment on that way.
No.
It's a lot faster. This just gives us more gadgets.
Yes. Yes, it's not going to remove the gadgets.
Yeah, so what you say is so like polar opposite.
It's at the same time, it's against the sustainability because you want to sell more gadgets and more new kind of gadgets, that kind of things. But at the same time, if you can, within the, first of all, the distances from base station to your user devices are going to be small, so the energy consumption per link is going to go down a lot. So you are saving energy in the future. Obviously, you need global coverage and national coverage that will be provided by 5G. And because this was what I was talking about, the revolutionary path of 6G. There will be also evolutionary path, which is providing coverage by spectrum refarming. But this is something that we have pushed into the global 6G agenda, the sustainability development goals, so that we at least think about it, try to figure out what is the best way to come up with system designs that supports the SDGs.